Okay guys, on to question 3. A block A of mass 9 kilograms is released from rest from a point P, which is a height h meters above horizontal soft ground. The block falls and strikes another block B of mass 1.5 kilograms. So this one has a mass of 1.5 kilograms and A has a mass of 9 kilograms. I'll say before we go much further, this is an irregular question. It is definitely the kind of question that you might, and that you probably won't have covered with your teacher as an example in class. So it hits block B, 1.5 kilograms, which is on the ground vertically below P. The speed of A immediately before it strikes B is 7. So if you think of A has an initial velocity of 0 because it says rest. And it has a velocity of 7 just before it hits. The blocks are modeled as particles. Find the value of h. You know that modeling as a particle simply means the volume is 0. Okay, so for the first one, we've got initial velocity, we've got final velocity, we need to find distance, we know gravity. Let's hit Suva. Okay, so what do we know? We know u equals 0. We know final velocity is 7. We know A, if we take down as positive, is 9.8 meters per second squared. And we know S, well, we're trying to find S, which in this case is given the letter H. So the only letter missing here is T. So if we look at the T formula, which is this one, so V squared is U squared plus 2AS, but U is 0, so it's just going to be V squared equals 2AS. So 49 equals 2 times 9.8 times S, which gives you S, which is H equal to 2.5. Now it's important that if you take up as being positive, your acceleration would be, in that case, negative, which would give you a height of, or a displacement of minus 2.5. Although a displacement can be negative, the h is the height, not the displacement, so it will always be positive. Okay, so you have to watch your scalars and vectors there. Moving on to part B. Just get the units there. Momentum. So here, immediately after the impact, the blocks move downwards together with the same speed and both come to rest after sinking a vertical distance of 12 centimeters into the ground. Assuming that the resistance offered by the ground has a constant magnitude R newtons. So this links back to the start where it says it's a horizontal soft ground. We need to find the value of R. So we're going to use the principle of conservation of linear momentum. So the momentum before of the object will be, if you think of mass times velocity of A, so A has a mass of 9 and a velocity of 7, plus mass times velocity of B, well, B has 0 velocity, so that will just come out to 0. And afterwards, we have a combined mass, so it's 10.5. So what is the velocity we will find? So that will just be 63 divided by 10.5, which will give you a U value of 6. Now, if we go back to our V squared U equals U squared plus 2AS, we now know the initial velocity is 6. We know the final velocity, because the system comes to a rest, is 0. We know that the distance traveled in the ground is 0.12 because it's 12 centimeters, so check your units. And we need to find A. So we're using the same formula again. So now 0 squared equals 6 squared plus, so it would be minus 2a times 0.12, which will give you an a value of 150, which is really big. So now, how do we find the force? Well, we know it's going to be force minus resistance is MA. We know A is 150. We know M is 10.5, the combined mass. We're trying to find the resistance, and the force will just be mg, so it'll be 10.5 g. So let's take this over here. So we will have 10.5 g minus r equals 10.5 times 150. Now if we check our signs, if we're picking down as positive, the acceleration will be a deceleration, so that would be minus 150. Okay? If you simplify all that out, you should get R equal to 1,680 newtons. Okay? If you got that, well done.